All right, can I get a quick wave in the back so I know they can hear me? Thank you. Thank you, Eli, for the introduction. I'm Daniel. In the second year of my master's at the University of Minnesota. I'm going to give you a kind of a quick rundown on floodplain forests in the upper Mississippi River. Floodplain forests on the upper Mississippi are aging, which makes them more susceptible to damage from things like climate change and invasive species. And managing these forests can be difficult because there's a lot of uncertainty regarding how trees and other plants interact with environmental processes such as flooding over space and time. So this project set out to investigate how trees interact with flooding and climate over space and time. Floodplain forests on the upper Mississippi typically experience flooding to some degree every 1 to 2 years, but the frequency, flood depth, and flood duration can vary at very fine scales. And in other systems, species composition is believed to interact with flood dynamics, so that's the case here as well. In addition to possible interactions with flooding, species turnover can occur at higher rates in upland forests. Species typically found in these systems are silver maple, green ash, elm, cottonwood, willow, and swamp white oak, the silver maple being the dominant forest cover type. Stands were selected to span a gradient of species composition as well as local hydrology. And on the right-hand side is kind of a subsection of the Goose Island stand, which gives you kind of an idea of the variation in microtopography within a site and how variable that can be in a very short space of time. So, cut to the chase, good stuff. Common plot level summary statistics like species importance value, trees per acre, or basal area, which is shown here, were highly variable within and among stands, even though they're all classified as the same type of stand. These are all considered to be silver maple stands. And we calculated these at the plot level to demonstrate that summarizing at the stand level can sometimes mask this variability. So next, we broke things out, categorized plots based on their local hydrology. So on the bottom is the average annual flood days during the growing season. And on the y-axis is the importance value, which in this case is a combination of the proportion of trees per acre and the proportion of basal area per acre that was that species on that plot. And we found that silver maple and river birch both increase in importance as the growing season flood days increase. One thing to note about this is these aren't all one events. This can sometimes be multiple events. So if you get to the 30-day class all the way on the right, that could be 10 3-day floods, that could be 3 10-day floods, it could be 1 30-day flood. Next, we took a look at increment growth of these species and how that related to different climate factors and inundation. So on the y-axis is a standardized ring width index, which I don't have the time to explain thoroughly. And on the bottom is the total growing season flood days for that corresponding year. So some species responded stronger to total flood days than broad scale climate patterns, which is a change from most endocrinology studies. And this was mostly seen in silver maple, which is these top 2 plots, but on the bottom is hackberry from another stand, and it was evident there as well. In other stands, silver maple showed little to no relationship with total flood days, and the different stand hackberry responded more to growing season rainfall than total flood days. Really trying to drive home the point that the local conditions has a lot more of an impact on composition and growth, which is probably pretty obvious to some people. Where you are is going to dictate how well it grows, but here it's at a much finer scale than we anticipated. So if there's one thing I want you to take away here, it's that there's a lot of variability within and among silver maple stands on the upper Mississippi River, and when you're designing prescriptions and management plans for these systems, we need to take that variability into account when it comes to things like inundation and rainfall at a fine scale rather than broad scale. And I have 7 seconds, so unless you have a really, really quick question, I'm just going to 4. Okay, great.